everybody. I'm really excited to talk now about Knative and how to automate your Kubernetes deployments with GitOps. And this is really like unintentionally actually building on top of the previous presentations from Eddie, from JJ. So thank you so much for that. It's providing a great base for me to build on. A bit more about myself. So my name is Anais Urlis. I'm a developer evangelist at CodeFresh. CodeFresh is a modern DevOps automation platform. We have CI/CD pipelines, as well as comprehensive tooling for you to automate your DevOps deployments. Now, if you want to connect for questions, suggestions, any feedback, and so on, I'm really active on Twitter. Here's my Twitter handle. And let's dive right in. So what are we going to look at? The title suggested a bunch of different tools, a bunch of different methodologies that we're going to look at now in the next 10 to 15 minutes. However, I won't comprehensively, I won't go into detail into those tools and how they actually work, but I want to really focus on the goals that those tools help us solve. So when I'm talking about Knative, I want to focus on how does it help us to reach certain goals. When we're talking about GitOps, it's a deployment methodology. What does it do for us? How can it bring us further, move further ahead? In our processes. And ultimately, I want to show you with a really quick demo on how you can build an automated CI/CD workflow, deployment workflow for your serverless applications. So what are the goals that we want to work towards? We want to have, now you can see it, I think. We want to have high portability, meaning we don't want to be vendor locked. We want to be able to move quickly between different infrastructures, different tooling, depending on our needs. Everything is moving really quickly with technology, and we want to be able to respond to those. And if we're constrained with the tools that we are using, that's no use for us. So that's one of our goals. We want to be able to respond to our ever-changing environment. Our team should be agile. We want to work towards having agile deployments. And this is only possible if we have high observability into our deployments. If we can see what is happening where, what is currently deployed, how is it a healthy deployment, is it working properly as it should be, who made the last deployments, what were the changes that were actually made, and so on. Now, to have all those insights, we could use existing tooling or we can build our own tooling. The problem is if we build our own tooling, we might end up spending more time actually taking care of those tooling, of those custom platforms, than about our actual application and the code that we want to provide to customers. So if our tooling, our observability comes at high operational management, that's no need to us. And in the end, we want to do everything. We want to move really quickly in a rapid environment without introducing additional security risks, right? We want our customers to be able to access our platforms, our products in a secure manner. So I'm going to make the assumption here, and I'm really thankful that it was introduced before, that we are going to use containers. We're going to use containerization tools such as Docker, and we're going to use Kubernetes to manage our containers as a platform, as a base. Now, Kubernetes, I'm not going to go into further detail. It was also explained in the previous sessions really nicely. Just think about this. It's our platform. It's our base that we're going to use to build other tooling on top, to use other tooling on top from this cloud native ecosystem, from this vast ecosystem that we saw earlier. Now, whether or not we're going cloud native or we're using traditional deployment workflows, here's what we don't want to have. Let's start there, right? If we want to develop a feature, if we're developing a feature, if our development team starts to develop a feature, goes with a back and forth with our QA team, makes sure that the feature is ready to be deployed, then maybe communicates with other teams across the organization to ensure that the security configurations that currently exist on our deployment don't break, our networking doesn't break, and at the end, we can deploy it. Now, this might be a workflow in a matter of days, maybe weeks, or even months, depending on how fast our communication is between teams, depending on what the expectations between are, what the logistics and the team size is, and how we can move these different pieces forward. Now, if we have interconnected processes within our team, whether those are cultural or whether those are technical, they will make it more difficult for us to move really quickly and make deployments work quickly. So if we have then on top of that a huge monolithic architecture of our application where basically everything is packed together in one way or the other with complicated dependencies between different parts of our application, it's going to be even more difficult to make this change, to make those updates happen, to deploy this new feature and respond to customer requests, right? So at the end, we sprinkle some really bad visibility on top of our deployments to sum it all up, right? So nobody really knows what's going on where. Obviously, we don't want that. What we want to have instead is a microservice architecture. So what we want is basically to have our Kubernetes cluster. So I don't know if you can see my mouse. Envision this box around microservices to be our cluster. And on top of that, we have different microservices. Now, each microservice, service 1, service 2, and so on, each run their own containers. They're using containers to basically provide their part of the application. Now, all of those together maybe provide our platform. Now, the cluster itself, the Kubernetes cluster, is going to take care of our networking and our security. We have set that up once really nicely. And when we make changes to different parts of our application, it shouldn't break any of our configurations. So once a client, a customer accesses one part of our application, it's going to be served with that part, with those resources, and we can make updates to different parts of the application without breaking our existing configurations. Now, why do we want to move into a cloud native direction? Why do we care right now about learning about Docker, learning about Kubernetes, see how this is all working and make the connections and maybe try it out ourselves? It's because we want to move from bare metal over virtual machines to containers, and then overall basically reduce the time that we spend on managing our infrastructure. We don't want to spend extensive time managing our infrastructure, over developing the application, responding to customer needs, customer requests, and so on. So once we had container and we use Kubernetes, we discover different tools that we want to implement on top of our cluster. We see this and all of those different shiny technologies that we want to use. Now, here's one of the criticisms that Kubernetes actually has. Because it is this really vast environment with different components, it might actually end up, like your team might actually end up having to take a lot of time to deploy those different components, especially when you're not using something like OpenShift or a provisioned Kubernetes cluster, right? When you're deploying everything yourself and you have to make everything work by yourself. So this is where serverless functions and serverless architecture and platforms tooling such as Knative comes in, that helps us to avoid this management overhead or to navigate around this management overhead. So these are the overall goals that we want to respond to. And this is kind of the direction that we use to respond to those goals. So what is Knative? Why am I talking about Knative right now? Why do I think it's interesting for you to know about tools such as Knative and that you can use that on top of your Kubernetes cluster and have really fancy deployments? So Kubernetes itself, if you're familiar with Kubernetes, is in itself a Kubernetes resource. It's a resource that you use to deploy on your, like you deployed it on your Kubernetes cluster, such as most other Kubernetes resources. It's basically some YAML files that you use to deploy it on your cluster, and once it's running on your cluster, and we will see that in a few minutes, then you can use Knative. Now, it consists of two different components, a serving component that's used to basically run stateless applications on top of Kubernetes, and then it has an eventing component. Now, right now, I'm only going to focus on the serving component. Now, the benefits of using Knative is that it provides us with a way of fast iterative development of our application. It's supposed to make our development really easy. Once we have it set up, and I will show it to you as well in a second, we can basically just tell it what application it has to deploy, what container it has to deploy, and it will take care of managing our Kubernetes resources for the most part. So our team ultimately can focus on the code of our application and doesn't have to manage the resources that are needed by our applications on top of Kubernetes. So it overall provides a really quick entry into serverless computing. Now, another really nice benefit of Knative is that it tracks different revisions of our application. So we start with one with our original version, let's say, of our application, we deployed it, and then we all of a sudden have a spike in our users. A lot of users all of a sudden want to access our platform at the same time. Now, Knative is going to take care to spin up different revisions of that application, so everybody can access the application at the same time. So automatically it can spin up depending on how many people request access to our application, it can spin up more resources or it can reduce those resources. At the same time, if we want to deploy an update to our application, if we want to have a new update, a new feature, something new, we can then deploy a new revision through Knative. So Knative is going to take care to slowly move from our old revision to our new revision. So it's not going to be deployed, our new revision is not going to be deployed within a big bang, but really gradually. And that provides us with higher confidence in our deployment. Now, like I just mentioned, if you're using Knative and you have it on top of your cluster running, and then you want to deploy an application, you would give it a simple YAML file. You would provide it with the resources with a pointer of where is your container, what container is it supposed to run. Now, if I do that on my local machine, the problem is that I would then run several commands to deploy it on a cluster. And if you want to do that on your machine, I would have to tell you those commands. I will have to give you the file and so on. And that's not really replicatable across several users, several machines, and maybe an entire team. So what we want to do instead, we want to use GitOps principles. GitOps in itself is just a principle of defining all of our resources within Git. So everything that we're using, and I promise you this is possible, we can define everything from the clusters that we are using on our cloud providers, wherever those may be based, to everything that our application needs. We will deploy all of that. We send all of that to Git. Now, this could be GitHub, Bitbucket, GitLab, any version control system that you're using. And then within Git, that's our desired final state. That's the state ultimately that we want to have within our cluster. So when we have a developer here, and the developer wants to deploy maybe a typo fix, it's going to make she's going to make the typo fix and then push it to Git. Now, once it's in Git, they're going to file a PR, and with that, they're going to say, hey, there's a new version of that application. It should be part of our desired state. Now we have here our cluster, and within the cluster, we have our different services. Now, the typo fix is within service 3 in that case, for example. Then the agent that we have deployed on our cluster is going to make sure that it's going to consistently monitor our desired state in Git. And if there's a change, it's going to pull that new state and deploy it on our cluster and make sure that the new version of service 3 in that case is going to run properly within everything that we want to have run within our cluster, within our desired state. So with that, with this agent is going to basically make sure that we have always the state, like a predefined state within our cluster, and any changes to our different applications, to our different microservices, is not going to alter that state. You can think about it this way. I went to a really nice Italian restaurant and I ate an amazing lasagna. Now I want to replicate the lasagna. I have probably a bunch of different ways to how I can go about it. I could just experiment around with different ingredients until I finally have that lasagna in front of me that hopefully tastes similar. Alternatively, if you want to make the lasagna at home and I want to make the lasagna at home, we can follow the same recipe and we are far more likely to have the same lasagna at the end. So basically, Git is going to provide that recipe that's then through the agent deployed on our cluster. So this is a way of defining all of our resources in a declarative format. The imperative format would be me to just go ahead and mix up different ingredients. So who's our agent that I just introduced? The mystery agent is going to be Argo. Now, in this case, we're going to use Argo CD. Argo CD is part of the Argo project family of cloud-native Kubernetes-based tooling. Argo is is part of this massive CNCF Kubernetes landscape that you saw earlier. And it's basically a CNCF incubator project. Now, if you're using Argo, Argo is going to have our desired state. It's going to know which Git repository our desired state lives in, and it's going to make sure that this desired state is going to be running on our cluster. It has a really comprehensive UI and a client, so if you prefer to press buttons or type commands, that's up to you. And also, we have seen earlier, there are different ways on how we can provide resources to our Kubernetes clusters. So we could use something like Kustomize, we could use Helm, or we could use plain YAML files. So if you're using Argo, you don't have to rewrite hundreds and hundreds of lines of YAML and then stay up until 3 a.m. in the morning to find that little space that screwed everything up. Instead, you just, you could reuse your existing working resources. So I'm a bit biased here because CodeFresh heavily integrates with Argo CD. We actually built on top additional functionality. So for instance, we have our GitOps dashboard. And the GitOps dashboard provides us with all of our insights that we probably could hope for on our deployments. So what we're going to do, basically, what the entire workflow is, and I'm going to quickly demo that in a second, is we are going to tell CodeFresh what our Git repository is. Now, since CodeFresh is integrating with Argo, it's going to then tell Argo what that resource is, and Argo is responsible. Argo can make that deployment on our cluster happen. So once Argo CD is telling the cluster, hey, there's an application that we want to deploy, or there's a new version of that application, It's going to be then sent to our cluster. And in that case, since we have Knative running on our cluster, Knative sees that, oh, this is a resource that's for me, that's under my responsibility, and is going to take care of those deployments and provision on the resources that are needed for those Kubernetes deployments. Now, within the GitOps dashboard, once we make a change or deployment, we can see who made the change, what pull request those changes respond to. I don't know if I can zoom in here. I will show you in a second on the actual CodeFresh UI. We can see when different changes took place and whether they are successful. We can see also the different pipelines that have been or they are used currently and have been used to manage those changes. Now, once we have all of this, we have all of our everything defined within Git, our desired state, everything, all of our resources are in Git. We have Argo CD running on our cluster to deploy updates. We have CodeFresh wrapped around to manage our deployment. And then we have Knative to basically provision our scalable workloads, our scalable serverless-based applications. Now, once you have all of that, we're ready to go. So this is now a quick demo. I'm just gonna stop. I hope you can see that. So yeah, you can see it, I think. So I'm right now here in my terminal, and if I look for my kubectl config, if I write it correctly, I'm right now connected to my Azure Kubernetes cluster. Now, you could be connected to any other Kubernetes cluster, to your cloud, Google Cloud cluster, or any other cluster. It doesn't really matter. What matters is what I have deployed on that cluster. So if I say get namespace, I can see here that I have right now, and we saw this earlier, those namespaces are basically separating our different resources one from the other. So in this case, I have within my Argo CD namespace all of the resources that Argo needs to run. So basically, envision this: if you install anything on your computer, right? Usually you need to download some files. You need to install something on your computer. And in this case, I'm basically installing Argo CD on all the resources that are needed for Argo to run on a namespace within my cluster. The same holds true for Knative. So once I install the Knative serving on this cluster, I have access to it within that cluster, and everything that communicates within the cluster can access that. That can access Knative. Now, Knative uses a service mesh, also mentioned earlier. In this case, I'm using Istio to basically provide a domain for my different applications and allow different containers ultimately also to communicate with each other. Now, I've already set up my applications here. So I'm just going to show you what I've set up within my normal namespace. So as you can see here, this is the important part. Well, this part. Let's look at this part. So I have basically two applications installed on my cluster, deployed on my cluster. They are both based on Knative deployments. So Knative is going to take care of providing the resources that are needed for those applications to run. Right now, I can have a look at replica sets, which is a type of Kubernetes resource that basically defines how many pods, how many instances of that application, of that container should be running in this case. So as you can see, it's all at 0, right? It's all at 0. And this here is just a revision of those different applications on through Knative. So as you can see, there's nothing right now, everything is empty. Now, if I go ahead and I open those applications, I've already have them open here. I'm just going to refresh them. So they basically know that they are needed, that they have to provide me with some information right now. So here is just a simple application that queries some articles from HackerNoon. So I'm just going to go ahead, look for Kubernetes. And now if I go back and have a look at my cluster, I should see those resources scale up. So as you can see here, of my revision 2 of my Hello World application, it's now saying, okay, it needs to run 2 pods to provide that request. And at the same time, my React application is also going to scale up. So before those were at 0, but now that there are requests to those applications, they are scaling up. So within the resources that I have given to my cluster, Knative can scale up the resources that are needed for those applications to run. So the more, like if you would access those applications right now, if you would go to the URL and you would basically check them out, then probably it would require more resources at some point. Now that I have all of this here, as mentioned, I don't want to actually manage this and deploy it through the command line, since you wouldn't necessarily be able to do that at the same time, or it would be really difficult for us to replicate it across multiple accounts. So I'm going here to my CodeFresh account, and I'm here within my GitOps dashboard. If I want to now deploy a new application, I would just go to Add Application and tell CodeFresh, the application, the Git repository that I want to add to my cluster, that I want to deploy through Argo CD. Now, in this case, I'm going to show you quickly the application that I actually used, the React application. So this is my GitHub account. This is just a repository within my GitHub account. As you can see there,
yeah. One thing, this is so exciting, but we're running close to the end of time. Yep.
1 minute?
Fine, 2 minutes.
I'm nearly done. I literally just need like 2 minutes and then Perfect. I'm done. Awesome. Okay. So I have here basically, if I go to that branch that was used, which is Knative demo in this case, I can go to my deployment repository, and I have here, as you can see, I have a YAML file. And YAML files, as we just learned, are used to deploy Kubernetes resources. And usually, to deploy all of those Kubernetes resources that are the replica set, the services, the deployments, and so on, to spin up the pods, to provide the application, and so on, right? You usually need a lot of different YAML files. In this case, I actually just need 18 lines of YAML, which is pretty cool, because that allows me to focus more on the application development than actually spending time on fixing the YAML files, right? So over here, I have my GitOps dashboard, and I can see the application as it's currently running. I can see that I made the latest changes. The pull request that the latest changes respond to. I can see the pipeline. Now, when I were to deploy a different, when I would, for example, update anything within my React application, it would trigger the pipeline. A new container image would be built. Then some additional information, such as the PR that is related to that Git push event would be added, or some Jira issues I might want to add, for example, for bug fixes or feature updates or so on. So later on, other people have context on what I actually deployed. Then I might want to run some tests, and I want to ensure that Argo is syncing the new state of my application with the state that's with what's running on my cluster, while keeping the desired state of that cluster. So this is all I wanted to show. I'm done now.